All right, getting started. Thank you so much for introducing. I am Duraisamy, a developer advocate at Snowflake. I've been an AI and data engineer in the past, but currently a developer advocate. And Josh?
Yeah, I'm Josh Reini. I'm a developer advocate as well at Snowflake. I spent a career in data science and then spent a lot of time doing eval and now get to work at Snowflake.
Mm-hmm. And for today's talk, it's all about donuts. So if you do not like donuts, or if you don't like ordering donuts, you're probably sitting in the wrong talk.
Or maybe that's the only reason you came.
Well, all right. So when you are building a donut ordering assistant, right? What do you think are the capabilities you will need? Like, what questions would you want to ask for that assistant?
Or maybe like, what's your favorite donut order? Crowd participation, anyone? What would you want help with? Old fashioned? How many?
How many?
Yeah. Okay, cool. Sounds good. Anybody else? Do you want to try this one?
Yeah.
Yeah? All right.
Yep.
I'd like an old fashioned donut. So as I ask this request, the first thing the agent is doing is it's determining the intent of what I asked. It says, I'd love to help me get an old-fashioned donut, and maybe when we want to place the order, I guess we don't have a location in Oakland, so maybe we want to place the location or the order in Atlanta, let's say. So it's analyzing my request. It's going to search and find the right donut, check to make sure that this donut store has a old-fashioned donut. The thinking seems to indicate that it doesn't, but let's see how that goes. So it looks like it didn't have an old-fashioned, but the thinking indicates it has some like similar donuts. Still working on the request. So it's suggesting a few different donuts that we might instead. Do you have a favorite of those three? Cinnamon twist, maple bar, or raspberry filled?
Cinnamon twist.
Cinnamon twist, cool. So it knows I've chosen the cinnamon twist, and it's just going to help me place my order. We're not ordering real donuts, so I won't charge you later. Don't worry. Nope. Cool. So in addition to kind of just ordering donuts, it can also help me decide what donut I want. So maybe I want to know like what donuts are most popular. And to do this, it has access to data about what donuts are being ordered at different locations. So it can query that data and figure out what's most popular based on what customers are really ordering. And it recommends the strawberry frosted as the best seller. So maybe we go with that donut. Let's take 6 of this one in Chicago's time. And I think you get the flow. So we can both order donuts and help decide which donut we want based on real data. And now I can pass to Vino about how this demo all works.
Yep. If you thought, guys, you just built a chatbot that could help me order donuts, really, that's not exciting. Well, that's not all, right? The data set that we're working with here is in the form of Iceberg tables in an open format, right? So again, like donut was the hook, y'all.
Who doesn't love donuts?
Bit into the right? We just love donuts, great. But also, like sort of like take a step back, extend it to a broader architecture of how do I work with the data that is sitting in an open format in any of the data sources, and how do I build an agent on top of that that is capable of answering questions on that open data? And again, it's not just about building an agent that can answer questions, right? It's really in the enterprise setting, an agent that can be trusted so you could publish it to your data consumers. Like if you're a data person or an AI person, building these apps for your employees internally or externally, how do I make this agent trustworthy? And how do I make sure this agent is able to learn over time? Like how do you improve this agent over time? That's the focus of today's demo. And as you can see here, for this demo, we have the data coming in from Iceberg tables, open data format in an AWS S3 bucket. And then I'm going to create a catalog linked database in Snowflake to essentially connect to an open data that's available anywhere. And Josh also has a couple of, donut menu reviews and other data sitting in Snowflake. And he's going to really build this agent that is capable of understanding structured data, unstructured data through, Cortex Analyst that Snowflake offers, and Cortex Search, which is, you can think of it as a hybrid search, including vector search at the end of the day, to give you that agent that is capable of answering questions across all of these data sources wherever you have your data. And as you can see, right, like I was talking about, in an enterprise, your data is really everywhere. Some proprietary formats, some, transactional databases, and some in open formats in a cloud storage. Your data could literally be everywhere, and you were still able to work with all of your data. The best part is that you do not have to move any data from everything into Snowflake. You could work off of that using catalog linked databases. Essentially, a link to your data external to Snowflake, and you could work off of it. So what you do is essentially build this unified data foundation that the AI expert can really work off of or make use of. And how do you do that? And as you can see here, Snowflake is an AI and data platform that gives you everything you need. But the focus of today's demo is really the data in cloud storage in open format, and how do we really leverage that to build our AI apps on top of it. And that one specific feature that allows you to connect to any data outside of Snowflake to work with is this catalog linked database, which is a bidirectional connection from Snowflake to your open data. It could be in any open format, specifically if you have Iceberg tables. That's the focus for today's demo, though. And that's pretty much it. But then you have all of the data, you build a unified foundation using that catalog linked database. You can't just dump this data over to your AI counterpart and be like, now build with it. But you need to add some sort of semantic layer on top of it. Add the business definitions, KPIs, metrics, and whatnot, along with really like the data dictionary of the data that you have, right? What are the tables available? What are the facts and dimension columns? And really the agent will have this additional business context from this semantic view to be able to answer your question. Can you can you write an agent without like a detailed or right semantic view? Probably. But would it be trustworthy to be able to answer all the questions right with high accuracy for user? Probably not. So this semantic view is your way of really packaging the data in a meaningful business context added to it before any AI app can use or make sense of it. Now, in the demo, let's see how we really packaged or built this unified data foundation, right? As you can see, this is the donut data that I had in my AWS S3 buckets. They were in the form of CSVs, but for this purpose of the demo, I wanted to have a bunch of Iceberg tables, so just so it's in the open format, which is available and can be queryable from any other open query engines as well. And you can see Iceberg table, data, metadata, donut orders, great. And these tables are, for me, managed by an AWS Glue catalog, which is one of the REST catalogs that Iceberg supports. And this looks great. So this is the location of the data, and this is the Glue catalog. And what I told you earlier was that from Snowflake, I will be able to connect to this data in S3 without having to move it in anywhere. So what I can do is to connect it is a three-step process. One, create an external volume, essentially point to the specific S3 bucket where my data is. Great. And the second step is create a catalog integration, because in addition to the data, because Iceberg tables also have the metadata, right, available, how do I access the metadata about these tables that is in an open format? I want to connect to the Glue catalog through a catalog integration. So now Snowflake is pointing to the underlying raw data and the Glue catalog. So it has all the information that it needs at the end of the day. So in the end, when I create a catalog linked database, which is just another type of database which is linked, meaning the data underneath for that database lives in the S3 bucket in the form of Iceberg tables, not Snowflake native data format, not proprietary to Snowflake, right? So you could work off of any data external to Snowflake using this one. And if I were to go find this, so this is, if you can see, the Donut Iceberg data is the catalog linked database that I created. And then under that, you see the Donut Vino DB, which is the same as the glue catalog, which is essentially this specific glue catalog is now replicated, not in a real sense, but like a point in time. I mean, a pointer to this glue catalog is now available through this Donut Vino DB schema. And then now you have your Iceberg tables, which were in open format in S3, available for you for further analysis in Snowflake tables. Now, with that said, we have only made the data ready. And how do we think about the semantic views, remember? Because it's not just enough to pass the data off to the AI team, but we also need to add additional business semantic context. And then I had created this semantic view, and it's essentially like, what are the tables available? And then what are the time dimensions, packs, and other dimension columns? And what are the metrics I might potentially run on these specific tables and whatnot? And you could even add relationships between these two tables, because if your end user might ask some questions that would involve joining a couple of tables. Or you could even, for example, add verified queries, like semantic views in Snowflake allows you to add verified queries. What is a verified query? Like if I'm a data analyst, we keep getting questions from our customers like, hey, can you quickly pull this data for me? And when you know what are the type of questions that you constantly get, you could put those bucket of those queries into verified queries so the agent would have at its disposal, these are some of the questions that I could expect from an end user when it happens. With all of that said, what we have done so far is essentially built the AI component of it, right? I mean, the data component of it. We made the data AI ready. But now Josh is going to take it over and tell us how to actually build the AI agent. Not just build the agent, but how do we improve it? How do we make it trustworthy and more?
Awesome. Thanks so much, Vino. So now our data is AI ready, and we can start to actually build what the agent looks like. So there's kind of two big components that we want to figure out when we're building our agent. So one is the tools aspect. What tools do we want to give our agent to work with different types of data and to take different types of actions? So the first tool we want to add is our Cortex Analyst, which is going to act over our structured data. This is a text-to-SQL tool, so we can ask questions in natural language, convert that to SQL using that semantic view that Vino showed us how to build, and then execute that SQL so we can get data back into our agent. And that's going to help us answer questions about like which donuts are the most popular. We also have a search service, so this is going to be over our unstructured donut menu so that we can determine which are the right donuts in our menu that are available to be ordered. We saw that when we tried to order the old-fashioned donut earlier, that old-fashioned donut was not in our menu, and we were able to figure that out using the search service. We also have some custom tools available to our agent. So the first is the take donut order custom tool. So this is what allows us to look at the conversation history and determine, all right, so we've mentioned a couple donuts, like what is the actual donut order going to be? And then the last set of tools are based on the donut customer reviews. So here we have some unstructured reviews coming from our customers about, I really like the strawberry glazed, or the raspberry filled donut is terrible, or whatever, what have you. And we have a SQL view that sits on top of that data that's constantly summarizing. So we get a refreshed summary, both overall and in the last 30 days in this like recent tool about what customers are actually saying about our donuts. So now we can ask additional questions. So here's another example of a question I tried. I asked what the most popular donut was in the morning. And it told us that people are ordering strawberry frosted, and then Boston cream is another favorite. And as I'm looking at the thinking, it doesn't really seem like it's able to kind of correctly filter in the morning, but it's kind of hard to tell, right? I'm just like looking at the answer. So one way I can kind of dive deeper into what the agent is actually doing is by looking at the traces. So here I have pulled up a trace of exactly what the agent is doing underneath the hood, what planning is it doing, what tools are being called. And you see it's taking 2 different Cortex Analyst calls. It's doing some SQL execution, and then it's generating an LM response at the end. I can see the inputs and outputs of all of those different steps, but importantly on the left, I can also use an LM Judge evaluation. So rather than manually looking at these traces and trying to figure out what's going wrong myself, I can let the LM Judge tell me. So the LM Judge determined there was an issue here with logical consistency. So we asked a question where we were looking to determine which donuts were most popular in the morning. But when we look at the explanation here, it says the agent acknowledges internally that it can't filter to morning hours, but it doesn't actually communicate this limitation back to the customer. So this is a clear gap and an issue with the agent that we've identified. So now that we've identified the issue, let's turn and see if we can improve our agent. So to improve the agent, I'm going to use Cortex Code, which is a CLI tool specifically optimized for working with data and working with Snowflake. And I've just pointed it to the donut agent so far. And if we think back to the failure mode that I've identified, we identified an issue where the donut or the agent can't answer questions about specific time ranges. And if we think back to the Vino's portion of the demo, we can understand that this is probably an issue with the semantic view, right? The Cortex Analyst tool doesn't properly understand the data and the features of the data to be able to do that sort of filter. So let's see if we can optimize the semantic view. And I've added 2 particular skills to this CLI so that it can help me optimize both my agent orchestration and the semantic view. So let's improve the semantic view so that my agent can answer questions about what's popular in the morning, evening, etc. So what Cortex Code is going to do, it's loading in the configuration of my donut agent from Snowflake. It sees that it uses this underlying donut semantic view, and it's learning about it, describing what the semantic view looks like, and getting the definition of the semantic view. I'll zoom in once or twice so you can see better. It's learning about the data, it's querying the data so it can actually understand what the structure of the data looks like. It's learned that it has a timestamp column that's going to be able to actually use this time of day data. So now that it's learned enough about the data, now it's going to start to modify the semantic view so we can actually add that time of day information back into the view so that we can actually answer that new sort of question. Seems like it made some syntax errors the first time, so it's gonna try again. And to do that, it has access to the Snowflake docs, so it can actually understand exactly how this should be set up and what the syntax should be. So it came up with a new insight now about actually how the syntax should be configured, so it's trying again. So we're still working on figuring out how to add that time dimension.
Making it a lot silly and stick that
It does seem like that, yeah. Absolutely.
What UI are you showing
So this is just a terminal. So yeah, just regular terminal. And then I just launch it with Cortex code, very similar to Claude code, but like optimized for data and how to use Snowflake. And then I've added two like sets of skills. So these are kind of like folders of markdowns that just like tell it how to do particular things. So on the agent optimization flow, it knows kind of the procedure should be like create a test set, try the test set, figure out what the failure modes are, and then make some changes in the orchestration prompts to improve against that test set. And then semantic views optimization, similarly, it knows kind of what the procedure should be to make those changes and optimize the semantic view. So it looks like it has now updated the semantic view with the time-based dimension, and it's just going to test the agent and verify that it works.
Okay.
Sorry? No, so this is all in Cortex code, which is just in my terminal. So it seems like it's doing well. It's doing a few more tests, and then once it gets done, we can actually go back to the agent like UI that we were looking before and just like make sure it works. So it seems like it worked well with the morning popularity question. It's just testing it with an evening question because that's what I asked for in my original task. Yeah. So while this is finishing, I'm going to just pop back over and just kind of describe how we can think about our evaluations. So at the end of the day, what we found is that agents work really well when their like goal, plan, and actions are aligned. And that's because when you think about how the agent operates, it first needs to discover the user intent of what the user is actually trying to do. It's going to articulate a plan on which tools it needs to call and when, and then it's going to actually make those tool calls, and it might need to replan along the way. So if we can start to define some metrics so that we can evaluate how well that goal, plan, and action are aligned, that can help us diagnose failures. So one evaluation we used in particular that we saw a second ago was that logical consistency metric. So this is looking at the alignment between all three, the goal, the plan, and the action. Determine how well all of these are aligned. Are there gaps where the system instruction says one thing and then the agent takes a different action? And that's exactly the sort of example we saw. So the user asked a question. It wanted to know what donuts were most popular in the morning. And then our logical consistency metric was able to tell that the agent made a logical error when it didn't communicate properly to the user, that it didn't actually have the ability to filter down onto morning data. And we have a paper that I can send you the link to as well. But what we found is that using these LM judges to measure these metrics, we can get to really close to human detection accuracy by looking at those agent traces and determining both when the agent makes a mistake and exactly what step it made the mistake on. So this is really useful. If you have ever tried to like manually annotate agent traces, it takes a lot of time. So if you can use LM judges to speed up that task, it's very helpful and can actually improve our iteration speed as we're improving agents. So let's go back to Cortex code and see if it's finished. And it says, yes, it can help discover what times of day or like what donuts are most popular at different times of day. So let's try it in our agent again. So let's start a new thread and ask the same question: what donuts are most popular in the morning? So now the agent is thinking, it's planning, it's figuring out which tools it needs to call. It's executing SQL. And now we were able to filter into the morning. So now we're super happy the agent now has this new capability. I think with that, I'd love to move into questions. If you have any questions on kind of the whole end-to-end story or like how anything's set up, we'd love to take it. Yeah, I think, can we share the slides?
Can you get any slides? Oh, yes. In the video.
Well, yeah, question in the front.
Okay, great presentation. I didn't know Snowflake had a Cortex code or a cursor code like product. So I think that's what one of the interfaces that we hadn't seen before that you were showing.
Yeah, yeah, totally.
So just confirming that. Is that agent GPA, that Venn diagram you were showing, is that a consistent way to judge? That's what it looked like you had, or Snowflake had established a metric called agent GPA, which is a combination of those 7 to 10 different evaluations. Is that what we were seeing, or can you teach me how to understand that?
Yeah, definitely. So I guess to answer the first question, so the Cortex Code CLI is new. We just announced it at Build, so it's in preview now and like will be more widely available soon. And then on the GPA question, so this is kind of a series of different metrics that are looking at the alignment of like these 3 different like steps of that the agent is taking, the goal, the plan, and the action. And the way you could think about this is that each are like detailed criteria on what the trace should look like if it is logically consistent or if the actions are adhering to the plan and things like that. So we won't like compute a composite metric, but instead allow you to have the individual metrics because that's what tells you actually like what went wrong. Like
How you did.
Yeah, exactly.
Planning or acting.
Exactly.
Yeah, so, okay, good. This is helpful. It's a good follow-on to our previous conversation about agent evaluation. So which of the 3 buckets is the part of the agent that we saw, and maybe it was where we saw it was in Cortex code, where it was just making it wasn't thinking very intelligently about where to put the as or whether a semantic view has a comment or not. You could see the agent struggling. So totally. Is that a goal metric, a planning metric, or an acting metric, or am I thinking about it the wrong way? Or
Different agents here, right? One is the DonutBot assistant agent, and that's the agent we were trying out in for the logical consistency part. But then
Cortex Code is another AI-powered assistant that helped us improve the semantic view. So Cortex Code lives and operates separately, and that's also an AI agent under the hood. It
has a low GPA.
we definitely could.
You know what? It's in private preview, which still means it's in beta. We just wanted to show you and see what's coming. So it's fair that it is.
I think your question is still important, right? Like the Cortex Code is also an agent, right? So like, what is it doing wrong? And when we saw it make those kind of like silly syntax errors, I would put that in like this like 5 bucket. So in between like plan and action, issues with tool calling, issues with like adhering to the plan. So I think like tool calling in particular is where I would expect to see like a low score on. Awesome. Yeah, thanks for the question.
We have time for one more.
Yeah, awesome.
It might not be direct to what you were presenting on, but one of the problems I
trying to get my head around is a lot of the queries that end up happening, like you've enabled access to sales data or to inventory or geo data on. And then some questions, though, will become like frequently asked questions. And I don't know how to categorize that kind of response. Like, you shouldn't have to do that whole thing over again for an almost identical question that you just looked up. But I haven't figured out with all these multi-agent operations how to automate the process of creating like a frequently asked questions response.
Yeah, this is a great case for like verified queries, and Vino, you can say more for sure. And so we actually have a new like text to SQL model called Arctic Text to SQL R1.5. And one of the cool things that I really like that this model is able to do is it can determine if it's looking at one of those verified queries. It'll like skip the thinking phase and just like generate the SQL from that verified query. Do you want to like say anything more about kind of how you like maintain and create those verified queries?
Mm-hmm. Yeah, firstly, I think it's part of the semantic model that he talked about, right? So you as a data person know what type of queries that keep coming up from my consumers, and then you can preemptively like add a query repository at the end of the day. So the agent, instead of thinking and going on the whole loop, would actually like a cache at the end of the day, right? Like you just look at the query repository and see if there is anything that I could directly answer by just running a SQL instead of having to do this whole thinking, reasoning, and acting on that. And second is, this is probably particular to Snowflake. So we also have something called a semantic view autopilot, which is people at Snowflake are running all sorts of queries against the data that they already are using. So when we do create these verified queries, how can we make it AI powered, right? Instead of me, a data person, having to write these verified queries and provide it to my agent, the agent can itself go look at the query history against a specific database and see what are the most frequently asked queries, and then sort of use that as a query repository for itself to sort of be smart about, how to act for the frequently asked questions.
Yeah, good. Thank you.
Yeah, thanks for the question. Out of time? Awesome. Well, thank you guys so much. Really appreciate it.